last question for this tutorial, question number 8. A certain source emits radiation of wavelength lambda equal 500 nanometer. What is the energy in kilojoule of one photon of this radiation? So we need here, given only light or photon radiation, okay, with lambda wavelength. This is the value of lambda wavelength. So lambda equal to 500 nanometer, should be in meter, okay? Then ask to find the energy, anyone remember the symbol, energy of photon? We see before in the previous hour in question number 1, energy of photon, W of photon or light. So photon or light, same name, okay? So energy, W of one photon. We need it in kilojoule, only given lambda. So how to find it? How to find energy of photon? Anyone remember from question number 1? Energy of photon equal what? Should be no. Energy of photon. We explained before in detail how to find how to find energy of photon. If we have here, if back to notes which are given in a question number 1, if we have two bands, the first one called valence band, yes, valence band. We have other band called conduction band. And if we have now, we have a source with the light, given the light, this light will reach to valence band, will be happen here. If given now photon or light, okay, this photon given in this equation with lambda equal 400 nanometer, okay? So what happened here? شو اللي يصير لما يوصل الفوتون إلى الفالنس باند؟ We said before, should be created one exciton. One exciton means one electron hole pair. One electron will be go to conduction band, so will create electron in conduction band and will leave in valence band one hole. So this photon will create one exciton. One exciton means one electron will be in conduction band and one hole will be in valence band. Always each photon create one exciton. Level 4, please. Should we know this note? Most of this question given depends on this note. So this note given in question number 1, we'll see for all question later, okay? So always any photon will create one exciton. Level 4. No. Should be given in a condition. This condition called should be find the energy of photon greater than the energy of band gap. Okay, so energy of band gap here between the two bands, this energy called WG, means energy of band gap between the two bands. And energy of photon here, energy of photon or light should be greater than energy of band gap to create one exciton. This note or this theory called 100% quantum efficiency. So if we have 100% or unity quantum efficiency here, that means energy of photon greater than energy of gap band. Here, each one photon will create one exciton. So if back to our question here, we need to find W of photon, energy of photon. Energy of photon equal to, depends on frequency. This value depends on frequency. So W of photon equal H times F. This value equal H times F, where F is a frequency and H called, anyone remember? H times F, where H is level 4. إذا ما تتكلموا حطوا السوليوشن وانتهى. أحط لكم final answer. يعني ما يصير حاضرين كم طالب حتى أكلم نفسي. 20 students. H called Planck's constant. Okay, where Planck's constant equal to 6.62 times 10 power minus 34 joule second. This is constant. And F is a frequency. F, frequency. How to find frequency? Now, depends on given light, any source of light, frequency will be, if given direct, same as a question number 1, we'll see direct. Also see this note in question number 5. How to find frequency if given lambda? Frequency will be
C
over lambda, where C is speed of or velocity of light. Yes, velocity of light over lambda. Lambda given now, wavelength. So should we find step number 1 now to find photon energy? Should be find, because H given, so should be find F first. So we'll find frequency. F equals C over lambda. C, velocity of light, so equal constant 3 times 10 power 8 meter per second. Yes. Then lambda given in a question equal 500 nanometer. So we need to change to meter. So 500 nano
multiply by 10 to the power minus 9.
So minus 9, yes. Then in meter. Now meter will cancel with meter. The value will be with unit 1 over S. And we know 1 over time will be frequency. So this is hertz. So will be, find please this answer. Frequency here should be find high frequency of light. Always high frequency. We see before given in tera. Tera means 10 power 12. So always frequency of light should be high number. So in this case, equal
6 multiplied 10 to the power 14.
Yes. So this is 1 over S, unit 1 over S means 1 over time, so hertz. Okay, so frequency equals 6 times 10 power 14. If given in a tera, now this is finished now. But if asked to find in tera, tera means 10 power 12, so will be how many tera? Should be times 10 power 12. So we'll take only 100, 2 zeros. So it will be 600 terahertz. So frequency here, 600 terahertz. Then step number 2, we need now to substitute in rule of energy. So energy of photon here equal to H, where H, Planck's constant, 6.62 times 10 power minus 34 or 28. Okay, I will check here. Yes, minus 34, yes. Joule second, then times frequency, where frequency equals 6 times 10 power 14. And this value with respect to 1 over S, where 1 over S equal hertz. So to cancel only this value, S with S. So we'll find now energy in joule. Okay, so this value equivalent to hertz. this unit I mean. 1 over S is hertz. So S with S, this is time, second. So we'll find now energy of photon in joule equal
3.972
yes, 3,
multiplied by 2 to the power minus 19.
So 3.7.9.972, yes, 10 power
minus 19.
minus 19 joule, given in a joule, this is the unit. So we need in this question ask to find energy in kilojoule. So we find in joule, so we need to change now joule to be kilojoule. So from joule to kilojoule, we need to find now energy in kilojoule. So times 10 power
minus 3.
minus 3, yes. So will be here, the final answer will be times minus 3 will be 3, same value, 972.
Plus 2 to the power minus 22.
Yes, 22, yes. So this is the final answer. Ask to find energy of photon in kilojoule. So this is the answer now. Clear? Okay, this question.
Yes.
Okay. So we'll go to next question. Next question, question number 9. Okay, question number 9. Given an ideal photodiode, one photodiode. Before question number 1, we saw 2 photodiodes. Now only one. So given an ideal photodiode is made of material with band gap energy equal 2.35 electron volt. So this value is energy gap, symbol of band gap, so WG. So WG equal 2.35 electron volt. It operates at 300 Kelvin. So this is temperature equal 300 Kelvin and is illuminated by monochromatic light. Okay, this is one type of light, monochromatic light, with wavelength, this is lambda here, lambda equal 400 nanometer. What is the maximum efficiency of this photodiode? We need to find the maximum efficiency. So here I will again return the data which is given in this question. Given an ideal photodiode, okay, with band gap energy equal 2.35 electron volt, given temperature equal 300 Kelvin, given lambda equal to 400 nanometer, should be in meter, and asked to find maximum efficiency of this photodiode. Okay, how to find maximum efficiency in general. In general, without this question, how to find maximum efficiency of any equipment, for example. If we have any system and we need to find the efficiency, maximum efficiency, should we know what? Should we know the input value with respect to output value. So efficiency, how to find it? Will be difference between output, input, multiplication of input, output of quantity, division. How to find it?
Difference between them divided by the first one, the actual number.
So this is error. This is error.
Yes,
Now,
yes.
yes. I'm need now efficiency. أقول عندي machine, any machine. Give, for example, input equal any value and given the output. So how to measure the efficiency? In general, efficiency always equal output over input. Output to input. So ratio between output value with respect to input value. So which value here given in this question? I'm back in general first without this question. Output to input. If we have, for example, a system with input, for example, voltage, and the output will be current, we can find efficiency output current with respect to input voltage. I mean with different quantity.
No.
No, should be find output to input with respect to same value, with respect to same quantity. So if you find as a power, so will be power output to power input. If you use energy, will be energy output to energy input. If you use any quantity, should be same quantity as a output with respect to input. Okay, this is in general. So efficiency in general will be the output quantity divided by input. Here now, we'll back to our question. Given, we know, given the ideal photodiode. What does mean by ideal photodiode? If given ideal direct, if given ideal photodiode, direct, that means there is a 100% quantum efficiency here because given ideal photodiode. So each photon should be create one exciton. Okay, so the first note here, I've written this note, because of, given in this equation, ideal photodiode, that means, therefore, we have here, efficiency is 100% quantum efficiency. What does mean by this note? That means each photon or light creates or relays one exciton. One exciton, and exciton means electron hole pair. Okay, so we're back here. Where's the input quantity here? Depends on this given data, and where's the output to find now the maximum efficiency? I need any value as input, same value, I mean, same quantity with respect to input and output. I will back to that diagram, small diagram for conduction and valence band. So this is conduction band and valence band, and we have a light, okay, with W energy, W of photon. We reach now, because we have now 100%, okay, quantum efficiency given ideal photodiode. So this photon, each one photon will create one exciton, and this one exciton will be one hole in valence band and one electron will be in conduction band. Otherwise, we have here gap between the two bands equal Wg, and this value given in this equation equal 2.35 electron volt. Okay, so there is any value as input and output. I mean power, temperature, frequency, energy, any two quantities as an input and output.
It is energy.
Energy, given energy, where's the input energy?
It is WBH.
Yes, so energy of photon, this is the input energy. This energy, W of photon, this is the input. So this is the input energy here. And the output will be the energy again of this light will reach to valence band, then back to conduction. So this is the energy here, the output energy. This energy called Wg, the band gap energy. So this is the output. So here you can find now maximum efficiency equal Wg with respect to W of photon. So because of maximum efficiency equal here, equal output energy over input energy. Therefore, now depends on our question, the output energy Wg and the input energy is W of photon. We can find, depends on this given data. Yes, because Wg now given, direct given, but given in electron volt should be changed to joule. Should be find, when find output to input should be used same unit. So we need to change the Wg to be in joule instead of electron volt. And with respect to energy of photon, we know from previous question how to find it. Okay, depends on previous question. We have lambda wavelength. So also here given the value of lambda. So can find frequency, then we'll find B of photon, I mean the energy of photon, which equal to H times F. Energy of photon, we know, equal H times F. So we need to find F because H constant, Planck's constant. So step number 1, find Wg in joule. So will be this value equal to 0.35 electron volt. How to change electron volt to be in joule?
Multiply by 1.6.
So multiply by Q, 1.6 times 10 power minus 19. Yes, will be in joule per electron volt. So electron volt will cancel together. We'll find now Wg in joule. So equal, this is the output energy here. Equal
3.76 into 10 to the power minus 19.
Yes, 3.76 times 10 power minus 19. Yes, joule here. The second value should be find energy of photon. So energy of photon equal to H times F. Yes, H times F. And F here not given direct, so we'll use the wavelength, given the wavelength. So H will be same, F will be C over lambda. So H, Planck's constant, 6.62 times 10 power minus 34. Yes, joule second. Then times C, velocity of light. So 3 times 10 power 8 meter per second over lambda. In this question given lambda equal 400. So 400 nano. So 10 power nano to change from nano to meter.
Minus 9.
10 power minus 9.
Yes. So here meter with meter, second will cancel with second, we'll find only energy in joule. So find energy of photon. So energy of photon equal should we find this answer greater than Wg or less than?
Greater. 7.5 multiplied by 10 to the power 14.
Equal, please, back.
7.5.
7.5.
Yes.
Then?
No, miss. Wait.
Miss 4.965.
Yes, 4.965 multiplied by 10 to the power minus 19.
Back, please.
4.965
4.65, yes.
multiplied by 10 to the power minus 19.
19, yes. Okay. So this is the energy of photon. So which one greater than other? Should we find the energy? We said we have ideal photodiode, so should we find the energy of photon greater than energy of band gap? This is okay. That's okay now. Energy of photon equal 4.96, approximately 5. And energy of band gap equal 3.7, approximately 4. So that's, yes, we have now 100% quantum efficiency. We have ideal photodiode. Okay, so now step number 3, we'll back to our note to find now maximum efficiency. We can find maximum efficiency as a ratio or multiply by 100 to find as a percentage. So first we'll find as a ratio. So will be 3.76, this is the output energy, divided by the input 4.965 times 10 power minus 19. 10 power minus 19 will cancel together. Also, the unit will cancel. So, ratio
0.757.
0.757. As a percentage, will times 100. So,
75.7.
So as a percentage will be times 100 will be 75.7%. Yes. Okay. Clear this note?
Yes, miss.
Okay. So now finish this question. But if back to our data which given in this question, we have other quantity given as an input and output. طبعا في الexam, if given in exam and asked to find only maximum efficiency, use any method, okay? So output to input for same quantity. Now finish this question. But in other question, if asked to find and given other question without, for example, energy, should be given energy. But if without any energy, or if we have different case here, we can find from this given diagram again, we have extra one value as the input and output. Which quantity here? ممكن أوجدها بدلالة other quantity given here. Which quantity we can use as an input and output? أحد يقدر يعطينا نوت؟ So in this case, this is the first solution. I mean, I will written only. Method number 1 can find. Method 1 depends on given a question now. Method number 1 we find using energy. We can find using frequency here because we have frequency of light. This is input. Yes, frequency of photon. This is input. We know this is the value of F. We find it from C over lambda. So this is the input value, input frequency. Also, we have output frequency here. Depends on WG. If we know WG means the energy of photon will leave the valence band to reach conduction. So this is again, this frequency will be depends on F. So should be find a new value of F depends on energy gap. Okay, so we'll use method number 2, depends on frequency. Method 2. So we'll find again maximum efficiency equal now output. We'll use other value frequency here. Output frequency with respect to input frequency. Output frequency we can written as same as a previous note when given energy as an output for gap and input for photon. So here we can written again same. So output frequency will be for gap, frequency of gap, and input frequency will be for photon. So we need to find frequency of gap and frequency of photon. We can direct apply by W is equal H times F. So we can find F. So step number 1. we need to find F, for example, of photon starting from input. Okay, written here, input. So input frequency F of photon, how to find this value? Equal for photon. How to find it?
H divided by
Because W of photon equal H times F. Okay, so F will be W of photon over H. So find this value, please. Or we can find direct. Why use it this one? Because we didn't have the energy. We didn't have energy here. In this question, this note, if we were starting from W, if given W, so we'll apply this rule for gap, but for photon, not given energy. So how to find frequency? Frequency direct we can apply by C over lambda. Yes, C over lambda. Because now in this case, didn't find or didn't given this value of energy. So C 3 times 10 power 8 and lambda equal 400 nano. So 400 times 10 power again minus 9. This is in meter and speed in meter per second. So we'll find frequency. So frequency of light or photon in hertz.
$7.5 times 10 power 14.
Yes. Hertz. Yes. 1 over S. So this is the input. Again, we'll find now output frequency. I mean frequency of gap. Okay, how to find frequency of gap. Now we'll apply the energy because energy given equal 2.35 electron volts. So can apply now rule of energy. So because of WG equal H times F for gap and H constant. So F of gap will be energy of gap over H. And energy of gap here given in electron volt should be changed to be in joule. So energy of gap equal given 2.35 electron volt. So will be times Q 1.6 times 10 power minus 19 joule per electron volt. So electron volt will cancel over H constant 6.62 Planck's constant minus 34 joule second. So joule will cancel with joule, remains only 1 over second, and this value is hertz, this unit. So equal to again should be find frequency, okay, because we have ideal photodiode, should be find the input frequency greater than the output one. So should be find now, this is for output, should be find this answer less than or greater than previous one. Now f of g should be greater than 7.5 or less than.
Less than 7.5.
Yes, should be less than. So fine.
5.6 into 10 to the power 14.
Yes, 5.6.7.68. Yes, 10 power 14 hertz. So the first one here and the second one here should be now the output and input one. So the output, the input, I will start from input, depends on 100 quantum efficiency. So the input frequency greater than the output one. So 7.5 greater than 5.68. So now we'll apply the rule. So maximum efficiency here will be output frequency 5.68 times 10 power 14 over The input 7.5 times 10 power 14. 10 power 14 will cancel together. Find in a ratio, and then find as the percentage value. Should we find same answer? If apply frequency as input, output, and energy and find different value, there is a mistake in one place, okay? So there is a mistake if find different answer, should be same. If you're using energy, power, frequency, any quantity output with respect to input, should be find same answer. So this answer here?
0.757, same before.
Yes. Okay, so as a maximum percentage will be again 75.5%. So same answer. Before we find ratio 0.757 and percentage 75.7. So 0.7, yes, 0.7 here. I'm written 0.5.
Yes, 0.7.
Yes, 0.7, yes. So 0.7. So this is the answer of question number 8, of question number 9, sorry. Any note here before leaving to other question?
No.
Okay, clear? So for our tutorial given now, we finished now question number 8, finish question number 9. For question number 8, this question repeated. This question same as in same tutorial, same as question number 3, and the question same as a problem 1. Problem number 1 given in solution in detail. Okay, what is the short circuit current delivered by 10 by 10 centimeter by 10 centimeter? This is area. Okay, of photo cell with 100% quantum efficiency, illuminated by monochromatic light of 400 nanometer wavelength with power density given 1000 watt per meter square. Answer here given. This question repeated, same as this question. So you have the answer of this question. So we'll go to question number 11. Question number 11. The solar power satellite radiates 6 gigawatt. Which quantity this one? 6 gigawatt. Energy, temperature, voltage. 6 gigawatt. Watt for power. Power.
Energy.
Should be power. Energy in joule. So this is power. And at 2.45 gigahertz. So this quantity here, you know, frequency. Yes. The transmitting antenna is mounted 10 kilometer from the center of gravity of satellite. So 10 centimeter, this is the distance. The distance between antenna and center of gravity of satellite. So this is distance. Okay? The question here, what is the torque produced by the radiation? We need to find torque. Okay? So I will back to, okay, this is a question. Now this is a question number, should be 11, not 12, because 11 cancel, okay? So given here, the power, this is the power, okay? So power equal 6 gigawatt. Given frequency equal 2.45, again, gigahertz. Okay, distance between the antenna and center of gravity of satellite equal 10 kilometer. And ask here to find torque. Find torque. Anyone know the unit of torque? Torque in which unit? So torque in Newton meter. In a Newton meter. Okay, so we need to first change the units, okay, to be in standard. So power given 6 gigawatt, we need in watt. How to change from giga to watt?
Multiply by 10 to the power 6.
Power 6. Power 6. This is mega. If power 6 mega. So giga.
Power 9.
9,
Power
9.
9. So 6 times 10 power 9 watt. Okay. Change from giga to be in watt. Then also for frequency, same, because given in gigahertz. So will be 2.45 times 10 power 9 again hertz. Okay, distance should be in meter, given in kilometer. So D in meter, need to convert from kilometer to meter. So times 10 power
3.
from kilo to meter. Level 4 or 3. So distance will be 10 kilometer. So 10 times 10 power 3 will be 10 power 4 meter. So we change all units, will be now in standard. So power given in watt, frequency given in hertz, and distance given in meter. So how to find again? How to find torque? Now from unit, torque will be Newton, use unit, Newton, meter. So Newton for which quantity? This unit. Which quantity use the unit as a Newton? This is force, yes? Force. Then meter for distance. So we'll use torque. Equal F, where F is a force, okay? And D is a distance given. So D given, we know D equal 10 power plus 4 meter. How to find F? So should be find F first. How to find F? Depends on given data. F, force. How to find force? Force equal power over velocity of light. So power given in gigawatt, we change to watt, and C, we know this is constant, equal 3 times 10 power 8. So we'll find first step, find force. So force F equal P, where B equal 6 giga. So 6 times 10 power 9. Okay? Over C. C 3 times 10 power 8. Okay? This is watt. And this one meter per second. So find this answer, please. Should be in Newton. Watt per meter. Watt second per meter will be Newton. So how many newtons?
20.
20.
20, yes. So 20 Newton. This is step number 1. Then step number 2, we'll back to rule and find torque. So torque equal to F, where F equal 20, times distance. Distance equal 10 power 4. So torque torque equal to
200 multiplied by 10 to the power 3.
so 10 power 3 kilo, yes? So
Yes.
200 kilo Newton meter. We can direct written as a 20 times 10 power 4 Newton meter. Or if take 10 power 3 will be kilo Newton meter. So this is the final answer for torque for this question number 12. So this is our tutorial for today. Any note?
No, miss, thank you.
Okay.